Hi, my name is Steve Kinney, and I am the head of front-end engineering at Temporal, and this is a course on Fullstack TypeScript. I created this course to take best practices from one code base and apply it across the stack, from the client to the server down to the database level. In this course, we'll cover how to validate types at runtime when they're coming from outside your code base. We'll also look at how to make sure that the data we receive on both the client as well as the server is what we're expecting. And finally, we'll cover tRPC and using ORMs to create a type-safe system all the way from the database to the server up to the client. Use these type safety strategies to sleep well, knowing that your software is reliable across the stack.
So let's kind of look at the core thesis that we're going to try to solve today in a bunch of different ways, which is a lot of times, we'll have this is obviously a very simple fetch request. We're just fetching some data from the API, right? We've seen it before. Call fetch, make sure the response is okay, translate into JSON, hope it's JSON, right? So on and so forth. And we could have a perfectly typed client-side app, but we have some problems here, which is out of the box, that response.json very quietly, it's of the type any. And any is kind of an interesting one because, if you have one any, it just bypasses everything, right? Nothing stops it, right? And so a lot of times you'll see in your own code, you can use something like unknown, which is assume nothing about this. I will have to check everything myself. Any will just pass right through any type check that you have. Even if, in this case, you didn't even type that any. Nobody in your team put that any there. That was courtesy of the browser or of the fetch API and the types that come along with that, right? And so there are strategies for at least getting, some type annotations around it, but a lot of those things are flawed. Right, so we can just say, hey, this get task is actually a return a promise with a task in it. Sounds good, right? And now it is what, I think it is. Emphasis on what I think it is, right? Because I'm just saying I could have gotten back literally anything from the API. I'm just going to tell TypeScript that it's, what I think it is and hope for the best. And that's useful for stuff like IntelliSense, but is it actually giving me any actual safety? Probably not. It's giving me safety after I've let it into the house, right? But I don't actually know what I let in. Because again, it is actually still that promise any, but we're just saying but pretend it's a task that comes out of here. Because an any will pass through anything. And so it passes right through. There's nothing yelling at you saying you didn't return a promise that resolves to a task because the any slides right through it. But at this point in your client-side code base, you can just pretend and everything else will adhere as if it was a task. The problem being, maybe it isn't, right? And it is one of those bugs that will definitely get you just often enough. Cool. So obviously the problem exists on the other side. So this is an express route, right? Where we've got a request body. And out of the box, as we can see, guess what that request body is? Any, right? So effectively, the browser, the client-side code, is doing a lot of trust that the API is giving what we think it ought to give. But on the same side, the server also exhibiting an equal amount of trust, right? That in this case, it is actually going to be the request body that we think it is, right? Again, we have similar strategies that we can try, right? We can do all sorts of, we can, kind of do a bunch of conditionals to see, so on and so forth. But again, at the end of the day, there is a certain amount, anything coming from the outside world is an unknown, but it's not even an unknown, it's an any, so. Let's start with request body. That seems like a good, fun one to arguably the most useful one. So it seems like a place where we know that we shouldn't have an idea yet. Really, what is technically coming in? We can stare at the UI and get a sense, which is a required title, which should definitely be there. Maybe a description, right? The product manager hasn't come to me yet saying they should be able to add a test that's completed yet. Why would you do that? Sometimes I do it to make myself feel good, where I'll put a to-do list and I'll check off the first things that are already done. Or in sprint planning, we do that sometimes. But like we can basically start by like, in the absence of a contract, we need to start reverse engineering a contract, right? And so the contract here is going to be what can both the client expect from the API and what can the backend service expect from the client, right? And so we can start here with the request body because like in this case, like we know that it is a required title and an optional description, right? So we'll just start by putting in this file. I'm gonna have to move it out in a little bit, but we'll start by putting it here where we might say that we have a, we could say we have a task schema. So we've got this object and we're gonna say that a task itself has got the ID that is number. It's not optional, I'll tell you that much. We're gonna say this is a string. Yeah, I think like because an empty string I think doesn't count. We'll see. I also don't know what my database respects now that I think about it. Like, can I store a title with an empty string? Does that? I don't know. Description is optional and completed is a Boolean that will default to false. That seems about right. So we have that task schema. We have then like we said before, we derive our other types as we saw in the previous exercises that we did, right? So we could say export const create task schema, which is going to be, we'll say, I don't need the ID in that case. Unclear if that's going to bite me. We'll find out together. And then the update task schema is going to be a partial, and I don't want to have an ID in there because I want to be able to spread everything knowing that I'm not going to write the ID. Other things that I might need is, this is a tricky one, but like, I don't feel strongly about this one. Like as a task list or task array, as an array thereof. Like there's sometimes like, oh, don't make a TypeScript type that is like just the array version of it. But then you got to type array other places. So like your mileage may vary. I'm going to do it right now. And so now I've got these schemas. They don't do me any good because they're not being used anywhere, right? But I can begin to go in. And this is the part where like towards the end, we'll look at like how to like generate whole like sets of like schemas and types and database queries all like automagically. But if you're an existing code base, that's probably not going to work for you, right? You can't immediately sometimes just whole hog generate everything. You kind of have to start at the painful part and begin to kind of like move towards the better lifestyle. Because in some cases you are going to have to like look at the actual API contracts and figure it out. So we'll start with that approach. So in this case, if we went down, there's lots of areas that we can do this. I'll do some of them, and I will make you do some of them, and it will be great. But let's start with this one, because this one feels like the most egregious. This is the one I'm going to try to put into the database, and like I should verify that it is what I think it is, right? And this is where we get to see some of the stuff we were doing those exercises in practice, where I can take this create task schema and just parse the body with it, right? And now my task is what I think it ought to be, right? It is no longer any, it has all of the correct typing. So here we'll have return client, and this was actually going to be that create task type. And again, it knew that partial task was not what I needed. That was that like weird fake type that I made earlier. It automatically knows that's not the type that the server expects. Give me the type that the server expects, please. Which is super cool. Return client.update task. And again, these are all defined on the server that says basically what it is looking for and what it wants, right? And like automatically enforces the types. And then you will see that like it is fulfilling all these explicit return types with no red squigglies. So out of the box, it knows the types the server expects. It enforces the types the server expects. It knows the types that the server gives back. It enforces the types that the server gives back, right? So like there's no necessary need to go and Zod schema the world, right? You basically will get the type safety as generated by the server, and all those long ones, right, simply become calls to the client, right? Either mutates or gets, and everything is type safe across the entire board.